Okay, we're moving on with our exponents. Just to refresh your mind, this is what we've covered with properties of exponents. We've covered negative exponents, boxing off, moving to the opposite side to create, if it's on the top, you move it to the bottom, if it's on the bottom, to the top, because an expression is not simplified if you have a negative exponent. So we talked about negative exponents. We talked about zero exponents. Anything to the 0 power is 1. And then yesterday, we talked about scientific notation and how that exponent tells us to move the decimal, either to the left or to the right. Those are the 3 concepts we've covered so far. We're going to add on. And we are going to talk today about the multiplication property of exponents. Your learning target, the same learning target you've had pretty much this whole unit. My goal for you is to simplify exponential expressions. All right, we're going to formulate this rule ourselves. I want everyone 3 to the 4th. What does that mean? How many 3's do I have? Write it down. 1, 2, 3, and 4. Times 3 to the 5th. How many 3's do I have in this term? 5. Write it down. 1, 2, 3, 4, and 5. Okay? Which is 3 to the how many? 1, 2, 3, 4, 5, 6, 7, 8, and 9. 3 to the 9th. 3 to the 4th times 3 to the 5th is 3 to the 9th. Some of you might develop a pattern. There is a pattern. Don't speak it aloud. Let's just form a hypothesis and then test it. Can you see the relationship between 9 and 4 and 5? Okay, let's test that hypothesis. What do you think this would be? You think it would be 2 to the 6. Now let's test it. How many 2's are right here? 2. 2 times 2. How many 2's are right here?
4.
Times 4 of them, which is equal to 2. That's my base. And how many 2's? 1, 2, 3, 4, 5, and 6. Ah, interesting. My hypothesis was right. So that's nice. I wonder if it's right here. Now notice they're the same base. Base means big number. So they're the same base. That's why this works. And also why it works, it's not only that they're the same base, but you have a multiplication sign in the middle. If it's add, you can't do it. It's only if you multiply. 4 cubed times 4 cubed, what do you think it should be? Your hypothesis says 4 to the 6. Let's test it. This is 3 4's, 1, 2, and 3, times, this is 3 4's, 1, 2, and 3, for a total of 1, 2, 3, 4, 5, and 6. So that is equal to 4 to the 6th. So what we're deciding is if you're multiplying by the same base, you can really add the exponents, correct? Is that what you're formulating as the rule? That is 100% correct. It's called the multiplication property of exponents. It says if you're multiplying powers with the same base, then you can just add the exponents. Now this is kind of fun to say. A to the n times a to the m is equal to a to the n plus m. Did you like that? Kind of sounds intense. A to the n times a to the m is equal to a to the n plus m. I sound like a genius, don't I? But it's just what you guys discovered on your own. I'm just putting it in generic terms, meaning I'm assigning variables to it. So x cubed times x to the 7th is equal x to the 3 plus 7, which is x to the 10th. Multiplying the same base. A to the 4th times a to the negative 3 is equal to a to the 4 plus negative 3. What's 4 plus negative 3? 1, which is a to the first, which is a. Okay, make sure you show all those steps because although you're getting this pattern right now, sometimes when you do that independent work, you might forget the pattern, and it's nice to just look at your notes. That's what notes are for. Utilize them. Ooh, biggest point of confusion, this next one with my 8th graders. Here's what kids write. This is a no-no. That's what kids typically will write. What did they do wrong? Share with somebody next to you. What did they do wrong? Okay. What did they do wrong? Jasmine, what did they do? The other b, right? This is really b to the first. It's not b to the 0 because anything to the 0 is 1. So this is equal to b to the 1 plus 3, which is b to the 4. Be careful for that. I can't be there with you when you do your independent practice, so you need to make sure to catch it yourself. We're going to bump it up a step by throwing coefficients in there. With coefficients, all you do is just multiply the coefficients, okay? Coefficients, you can just multiply them together. And then you add the exponent. So, what I mean by that, 2x to the 4th times 3x squared, write it exactly how I'm writing it, is equal to 2 times 3x to the, now they're the same base, so I can just add them. X to the 4 plus 2. 6x to the 6. Now I don't ever show this when I do my math with powers. I go right to this step, but I want to show you how I got there. That's what you need to be able to reference with your notes is how did she get that answer. I multiplied the 2 and the 3, and then because they're the same base, I added the 4 and 2. Okay? Going to more than one variable, all you do is combine the shared bases. Okay? So box off shared bases. That's what you care about, shared bases. Box it off, shared bases. Okay. So what can I combine the x with? Do I combine it with the y, yes or no? No, this should be x to the 3 plus 1. Do you agree with me? Yes or no?
Yeah. Yes.
Okay, I need to see students writing. Y to the what? Well, you get 9, but how do you get 9? What did you do? 4 plus 5, which is x to the 4, y to the 9. I love it. Exponents are nice and they're fast as long as you remember the patterns, the rules, the tricks. This turns into, now I'm showing every step I'm doing here. 2 times 7, do you agree with that? Multiply the coefficients. A to the what? Tell me what? 3 plus 2. B to the what? 4 plus 6. C to the what? 5 plus 2. Now you do not have to show all that in your homework, okay? You can go right to 14, A to the 5th, B to the 10th, C to the 7th. You can go right to that step, okay? You definitely can. However, with your notes, you need to know how I handled it. Any questions on this yet? That's the end of this part, isn't it? That's the end of this part. Tomorrow we're going to talk about scientific notation in this. I don't want to throw it in today.